Welcome everybody to the Advanced Framing of High Performance Buildings with Less Lumber webinar that we are having. We're Passive House California, and we're part of the Passive House Network, which is in New York, the IFA, Passive House International Passive House in Germany, and Passive House Institute as well. And first of all, I want to thank the Southern California Edison for bringing up and for coming up with this and putting it together. Very pleased about that. Just so you know, on December 3rd, Southern California Edison has another webinar that we will be hosting called about right-size plumbing in homes and apartment buildings. It's about code changes that have gone on. So I wanted to let you know about that. The link to this to register for this will be in the chat. We have links to that and our next community meeting, and we have another meeting coming up next week with 475. Want to thank our sponsors, our silver sponsors, Small Planet Supply, Minutair, and Earthbound Homes. We really appreciate them being on board as silver sponsors. And then we have supporting sponsors across here, 475, who's giving the presentation next week, Rockwolf, Fergus Garber Architects, Ream, Hayward Lumber, the Heinrich team, which is a realty team, Pete Moffett Construction, Stiebel Eltron, Intelligent Membranes, Pasoko Good Space, and we just recently got Icon as well that are in. A couple other things that I thought would be worthwhile to show is this is an advanced frame. You see some advanced framing here, but if people are on the program and are thinking of doing advanced framing and doing it, stop getting a group in to take a look at it and learn about it during the time that the building is being built is a good way to do it. And we've always done that at Carmel Building and Design. This was the first building that we built that was Passive House and on the west coast of California, first on the central coast of California, and it won the Fine Home Building Magazine's award for Best New House of the Year, and it was the very first advanced framing home that we had built or that we think is built out here. So that's how it works. So this is advanced framing high performance buildings with less lumber. I'm going to stop share now, and Ron will step up and introduce himself, and away we go.
My background a little bit, I've been a carpenter and framer all my life. Right out of high school in the 70s, I started framing room additions and custom homes, and eventually got my contractor's license and started doing bigger projects. I worked with Bonneville Power Administration in the 80s, doing beyond code homes for the future codes, and kind of just kept going with that building science all the way up through the present day. So it's kind of, I've been down this rabbit hole a long time. So you guys probably know a lot of this stuff, and some of it may be new and some of it review, but I just want to share a little bit what I've got, my experience on several projects too. And just basic topic of learning what lumber is, what's the parts and pieces. So that'll be the residential basics, framing basics. I guess it's not just residential either, like commercial also uses a lot of lumber. But we want to talk about how to, I want to learn ways to use the minimum amount of lumber to do the job. I know we've been framing things for a long time. We always think of there's just the way we've always done it, and we're used to seeing a piece of wood in a certain spot just because it's always been there, and maybe it should be there and maybe it doesn't have to be there. So we're going to explore some of that. And then we're going to talk about framing factors and how they affect your energy design rating and Title 24 compliance. And also, and I know passive house people, you're really big on this, is the building envelope leakage. So I probably won't be teaching anything new there, but we'll cover that. And then the payoff with advanced framing is obviously the savings in lumber, but it's time too and money. So, and I don't know if we'll get into this too much today, because this typically we teach a 3.5 hour class at the Energy Education Center in Irwindale and online. And I don't know if we'll have time to get into the Title 24 too much today. But let me give you well, I consider a great definition. This is from a project we did about 10 years ago. And this was out of our report. Will Vicent wrote this. He's in charge of the deputy director of the Title 24 CEC, so he knows of what he speaks. But advanced framing techniques are a collection of wood framing strategies that reduce the total amount of wood used to construct a building and increase its effective insulation potential while maintaining the home's structural integrity. I just thought that was just a great sentence out of our report. It just captures the essence of what advanced framing is. And I was gonna say, if anybody has questions along the way, I don't know, Jay, if that's something you guys are open to. If you want to ask questions, I can try and answer them as we go. So like I mentioned a little bit earlier, we've always done it this way. And yes, I know, like I did too. And when you're framing a wall and there's a window or a door opening, the trimmers go here and the cripples go there and the headers across there, and everything's got to be in its place. And if it's not there, it looks like somebody's smile with a tooth missing or something. You want to fill it in, but it's not necessarily needed. So in the big picture, we want to take out lumber that you don't need, replace it with insulation, and improve the efficiency and bottom line on your building and your building project. So as you probably know, as being passive house geeks, and I mean that in a good way, you know that the building is a system. You know, you got the energy modeling as part of it. You want to utilize that modeling to lower your framing factor and gain extra energy savings. But you want to optimize what the framing that'll affect the performance. So we have a thing called the framing ratio. So our framing factor, so take a whole wall, for instance, if it's say 10 feet long, and 25% of that wall is solid wood, then that would be a 25% framing ratio or framing factor. If it was 10, it would be, it'd be 10% solid wood, it would be 10. Framing ratio would be 10. And learn framing lingo like OC on center. It's not Orange County. Air leakage in buildings is actually more important than previously known. And I'm speaking to the choir here in this group. I'm sure you guys know about that. And structural insulated panels are a great way to meet these goals in a lot of ways. I've built quite a few different SIP homes and construct commercial buildings over the years, and I really like it. Actually built with a lot of building systems, but SIPs are one of the best. And then fasteners, extra nails are not always better, also known as split wood. You get too many nails in a piece of wood, especially an inferior one that has coarse grain and is extra dried out, it tends to split out and then it's not holding anything. But the really great thing is that a lot of people don't know is that you can leave a lot of lumber out of the building and still meet code requirements, which means it's still structurally sound. So I thought we'd go over just a few of the parts and pieces and kind of get familiar with some things that when we're talking about a cripple, or I don't know if there's a pointer version on this. See if I can.
We can see your cursor though, Ron.
Okay, thanks, Dave. I'll just use the cursor then. I was trying to find a laser pointer on this. So might as well start from the bottom up, since that's how we build anyway. You got a sill plate on this particular framing model here. This appears to be either a second story or could be on, a crawl space situation. But you got a sill plate, bolts to the foundation. Well, here they got a header joist, so they're going to have, that's carrying a load below. So this to me is the second floor. And then you've got, they call this door bucks, or they're called trimmers also. next to where their door jamb attaches. And then the lumber that goes alongside the header is the king stud. This horizontal piece here is a header, and the short pieces above the header to your double top plate there are cripples. And like on this window framing, you've got cripples above and below the window framing. So this is more, I'm going to say this is maybe more of an East Coast version. They use terms like jack stud instead of cripple stud. It's just different parts of the country use different terminology for the same parts. And here's your rafters. This is actually an older style stack frame roof. You don't see that too often anymore. It's more trusses, and we'll get into that a little bit too. Ceiling joist is the horizontal piece across your ceiling. And then they would have the same on the floor. They're not shown here, but by seeing that header joist here, they intend, I'm sure they were having floor joists across this floor. And here they're calling here's your top plate. Here they got your common rafters. You got cornice. We call it sometimes fly rafter, the one that's out here on the eave. And this is called an outrigger. Some people call that a barge or a barge board, and these are barge rafters. So there's different lingo for different parts of the country, but it's pretty much the same parts. So this is over at Irwindale at Edison's Smart Energy Experience within the Energy Education Center, 6090 Irwindale Boulevard. It's a great place. This is just a little corner of what's in there. A few years ago, we built this. I was involved in building this display that has a lot of different, I think we got 8 different examples of meeting the code with all sorts of different framing, coatings, insulations, roofing, just the whole bit. Different. You can see here that each one of these is different. This second one here is actually a SIP panel, and we just got a few different really cool things there. But just going over the parts and pieces, we talked about the plates, sill plate. Sometimes it's called a mud sill. Trimmers, the studs or king studs, regular vertical lumber in the walls is considered just a stud. King studs are alongside the headers. Jack stud or cripples, they don't go all the way up or down from the top. They're interrupted with an opening, and the header carries the loads. Rafters, we talked about, ceiling joists, floor joists. The rim or band joist goes around the perimeter of your floor. Purlins, that's up underneath the rafters, perpendicular to your rafters. Knee walls and pony walls, they're in the attic, and we might be able to see can't remember if I have an example of that, but they're kind of what the name says. It's a short wall that tucks under your rafters in the attic. And then you got soffits and drop ceilings within this interstitial space, like in a hallway or something for making space for ductwork and things. So not to beat the dead horse too much, but we want to just to help learn this. Here we go with an advanced framing diagram here. Notice how things are stacked one on top of the other. So you got it's point loaded all the way from the roof down to the foundation. And if also notice, instead of a double plate, we've got a single top plate. And you can do that by code as long as you do it correctly. This one shows a truss system here, but everything lines up as long as you're within 1 inch offset of your stud. Like if your rafters offset an inch, you're okay within an inch. And then you can leave out trimmers like here you see these hangers that are holding up the header. I understand that makes kind of a thermal short, but if you're using exterior rigid insulation, that kind of helps take care of that. And you've actually increased your insulation in the walls. And despite my always wanting to put a cripple here when I was framing, when you're nailed through this king stud into your sill plate or your windowsill, there's no way that's going to fall down. You don't need a piece of lumber right here, but it looks good. It's just what we're used to. You can do two stud corners right here. There's what you want to definitely have continuous insulation into your corners as much as possible. No dead space behind it like what we normally see with a California corner. And you can see, like I had over here, a single stud at the rough opening. So I know there's times when structurally you got to have more there, but very often you can do this, especially on your top floor. You can certainly almost always frame this way. And then you're obviously sheathing the exterior. I prefer a continuous sheathing for seismic, but I'm not an engineer, but I just figured cover it all. But I notice here they don't have energy trusses or the raised heel trusses, but we'll get into that further on. And on each of these, not every slide, but throughout the slide deck, we've got um, we show the code reference, but also some little references for you to go through and find some extra details and just supporting information that'll help educate you on this. And like I mentioned, ideally all the framing should line up. And this is a great little picture here, just with the arrows showing everything point loaded down to the foundation. Okay, this is a group exercise. You don't have to answer, but you're welcome to. Just what's wrong with this picture? Just kind of take a look at it. You can see there's outlet up here. The plumbers haven't been here yet, but the electrician's been here. You can see they've cut some of your framing out here for an outlet, or maybe it's going to be a switch. But what they've done is used quite a bit of lumber and on this project. And I talked to the architect. This was actually a Z&E project, a multifamily building that we worked on many years ago. Well, 6, 8 years ago. And they told me the reason they had so much lumber around this window was just for architectural look. They wanted this look right here where the window is inset in the wall. It's not just a flush. It just kind of adds a little dimension to a flat wall because they had a lot of windows. So that meant that every window had this huge perimeter of solid wood. So typically framing lumber is about R1 per inch. So where they have these 2x4s, your R3.5 that the window is attached to, and then the rest was 2x6. So you got R5.5 plus the sheathing. So you got R6 on those areas versus their design was probably at least R21 on that wall. So you had this huge section, plus obviously the window R value is much lower than the wall. So in a sense, you had big R holes in your wall. The R rating is way down. So let's talk about that. That was a big thermal short in the wall. And I'm gonna ask another question. What's wrong here? What are we seeing in this thermal image? Well, for starters, the ceiling here is nice and orange looking, which it's a lot warmer than say this wall. I took this image, it was summertime, it's probably about 10 in the morning, and this was an east facing wall. So it had insulation, it wasn't too warm, but you could see it had no external rigid insulation. So you could see the framing was transmitting heat gain coming into the house. So and the cooler sections was probably the fiberglass insulation in the walls. Now in the lid here, you got the exact opposite going on. It's hotter between the framing members. It's cooler on the framing members because they have a tiny bit of insulation value. And at this time of the morning, the framing hadn't really heated up and there was no insulation in that attic whatsoever. So you're seeing that's exactly what you had coming in your house. All that heat is radiating into the room. So you had on average over 90 degrees heat in that room. So you can imagine how their air conditioner can't keep up with that in the summer. So an infrared camera is a great tool. That in conjunction with the blower doors, it's mighty tools. And then any kind of smoke even helps even more. So let's take a look at some stuff in real life. On the left here, they tried some stack stud framing, but it didn't. It started out fairly close, but not everything's really lined up like you'd want it to be. They got it right here is good, and over here not so good. But they went ahead with the double top plates, so they were excuse me, so they were okay with it. But you can see that they've got started with it. And then, with advanced framing, it's not a all or nothing kind of thing. You can take one thing at a time and build on it, or you can do two or three things. And I'm going to go through some of those piece by piece. Here's a modern frame building that we were working on. It's all trusses. So in a truss situation, you don't have purlins the same as you did with an old stacked roof, the way they used to frame. So kind of all these 2x4s that are nailed along the perpendicular to the truss runs kind of help keep the 24 on center. So we kind of just call them purlins, but technically I suppose they're not like old school purlins. Like here's an old school purlin right here, like I was explaining. It would be up against the roof rafter, and then you'd have bracing down to your bearing walls down below. And I can tell you from personal experience, they're rarely this nice and neatly spaced and angled in a real house because walls aren't always in the right spot to get support to the roof. So you gotta get creative with your bracing. Okay, let's do a little deeper dive and talk about the purpose of each piece of wood. Now, I found this photo somewhere, and if it's anybody's project, don't get mad at me. I don't know whose it was. I gladly give credit, but it was just a great example to use just to learn about what can be taken out of the wall. And obviously, there's a lot of extra wood here, and I don't know the story of why everything is there, but let's just start with one corner here. So as you know, if you've ever framed a house, you know that on your double top plates, the plate that it's actually nailed to the studs, if if there's a joint in that top plate, it needs to be over a piece of framing lumber. So rather than cut this one shorter and have a split over the existing stud that you may have to have there anyway, we just wherever it ended, they threw an extra stud in, is my guess. So there's a stud that could be left out of this wall with a little forethought. And then over here we've got this little section here. These three studs has an uninsulated space behind it to the exterior. This is called a channel or a T-post for another a wall intersection that will attach right there. And you can use ladder backing instead, and we're gonna have some show an example of ladder backing. And then we've got multiple studs here. Well, I would call them, that looks like about 3 king studs in a row, 2 trimmers in a row, and then you've got a stud sitting over here with a gap. I'm not sure why, but there's just plenty of wood there. Now, do we need all this header here? I'm thinking maybe not, because look up here, we've got a beam that's running clear across this window opening. So if they design this to carry the weight, then you really don't need this here. They're having, say, floor joists were coming across the room above the window there. You really don't need this. This becomes a non-bearing section as long as this beam spans past the opening without a joint in the beam. And then we've got a bunch of cripples. We don't need that. This top plate's not going to fall down if these two cripples here are missing, or these two over here. And then, of course, we've got additional redundant studs over here. And if this is a 2x6 wall, this could go to 24-inch on center instead of 16. And then we've blanked out the trimmers under this window header because not only is it, I'm going to say it's non-bearing, but you can also, to carry the header, what little header you would need, you can have a framing anchor there. And you can also make this into an insulated header too, which we'll talk about a little bit later. So you can see that you've got, this is kind of, if you back it up real quick, you see the beam on the top. Now look down here, you got the same kind of setup here. They're using I-joists for their floor joists, which is great, the engineered lumber. But you notice they've got across this opening, this window, their header spans completely across, and you don't have to stop it like right at the window. You can just run it on out a little bit, and that will suffice to carry the load. So this becomes non-bearing. So you can use a 2x6 flat there, and all this becomes insulating, or insulated area above the window instead of having a big heavy header here as well. Just because of the design of this two-story, you could do it this way. And then once again, we've got your code reference here of where to find this particular layout in accordance with R602.7.5. And we may, I can see we may need to update this. This is still referencing 2015, so it's probably time to do some updating. But you can see that the rim header splices are not permitted anywhere over the window opening or the header span. And I've gotten a lot of great info from the APA, American Plywood Association, and I will share some links to their material too in this. So, you can do a single ply header or double. It depends on your opening and what you got going. And there's cases, I don't know if it's that way anymore, that maybe you have to use metal hangers, but we used to be able to block between these and use just nails by continuous blocking between these, as long as you had at least 1.5 to 2 inches bearing on that wall below. So, oh, here we go. Joist hanger required where bearing length is less than 1.5. Okay, so you could still go without these in the right conditions. But I think people like using hardware just in the seismic areas just as an extra layer of insurance for less motion in a shaker. Now here is a project that I was involved in a little bit up in Stockton, and this I was only I was there kind of at the end, and I just was really impressed with George Kortzen and his group. They were building these Habitat for Humanity homes and having the college students would come and help and learn skills, and it was just a great deal. And George was so good at this, he kept designing better and better homes using less and less materials and more efficient. And he got this design down here pretty good. This is right out, and they actually put a book together, Rick Chitwood and George and Mike McFarland, a few others worked on this, and what what they've got going here is they've got wood trusses, the energy truss, or excuse me, raised heel truss with a single top plate, and they found of a place that they could get OSB, in a 2x6 dimension, and I believe it was close to 30 feet long. So he could have most of his walls have that single top plate all the way through without any joints. And he also figured out how to do the shear panel over top of his insulation on the outside. So he had his rigid insulation actually attached directly to his framing. So I'm not sure what he had going there with the engineering, but he insisted that it was all kosher. And then you see these notches on the header, so he could leave that section of header out because everything was stacked right over the studs. He left that out temporarily. Whoops. I don't know what happened there. Got a little preview. Trying to get the cursor to show up. So you see these notches right here. They're notched for removable headers. That way they can insulate completely and then put the header in later on. That was something that he liked to do. And obviously we got just a single king stud there. So he ran his header on through the king studs. And if you'll notice also, when you use the raised heel truss, you can run your OSB sheathing all the way up and capture the ends of those trusses. So for extra hold down power and shear power, so it actually makes a stronger framing system. So, and then of course, then we got the single sill plate, no cripples down below, just that one in the center, and he's 2-foot openings. So this is a book. We can look it up. Real World Zero Net Energy Homes for California, and this is done through a CEC grant, EPIC grant 16-001. If you want to get a copy, it's a great book. Okay, I mentioned this a little bit earlier with the channels or troughs or T-posts. They got 3 names that I know of, and there's probably more somewhere. But the answer to that is the ladder backing. See right here on the left side, this is where the guy that's making that channel right there would normally put that to intersect this interior wall. But we've got ladder backing, so you can get full insulation behind that. I mean, obviously it's not 100%, but you've got this backing in here. But that way you don't have that cold, uninsulated corner there, because it ends up being a pretty wide section. You got a 2x4 on edge, 2x4 flat, and then another 2x4 on edge. So you get 6-7 inches of basically no insulation every wall intersection. If you take a look at this wood, you wonder why it's kind of pink colored. It's because they pre-treated it with a pest and fire resistant material. I don't know if they did it in a kiln or they sprayed it, or I'm not sure how they did that. But this whole project had that same lumber. But also, once again, here's the code reference for using ladder backing in lieu of the old style corner intersections. That's a pretty easy one to implement right off the bat. If you've never done any advanced framing, that's a good one to do. Here's a close-up of one of our displays there at the Energy Education Center in Irwindale. It's got some interesting things. We used plywood here for the top plate, 1.5 inch thick plywood. And any place you have a joint, a connection, like at a corner even, or in line, you still have to have a joint over a stud. But like say at this corner, you still need to add a metal connector at that location, because normally your double top plate would take care of that connection. And then here's an example of an insulated header. We've got plastic over that to keep people from poking holes in that expanded polystyrene. But you can get higher densities of this foam as well. You can get, typically it comes in a 1 pound density, but you can get a 2 pound density. It's a higher R value, and when it's glued, if you glue it to the lumber, it actually adds some structural strength. But that's more of a SIPS thing. I learned that from SIPS panels, different ones I've used. But we made up this header just for the display here. And there's a example of a staggered stud wall in here and ladder backing. And here's the 2 stud corner right here. So it's fully insulated both directions, other than the corner stud here. Obviously got thermal shorts. Each place there's a stud, but it reduces the thermal shorts uh, dramatically. And here's a quote from Rick Chitwood. He's now retired, but I enjoyed working with him. He says, the nationwide research shows framing factors at 25%. I've had the same experience as SCE with production builders saying they're doing advanced framing. Well, they seem to only get down to about 20% rather than mine and Habitat Stockton homes in the 9 to 11% framing factor range. So it's easy to get a little bit, but it takes a little more work to really get that framing factor down there. And once again, here's our code reference down in the right-hand corner for the single top plate. And that lets you get there. And it's a good idea to go to the building department. If you're gonna do advanced framing, go them first with your project and just talk to them, and rather than wait till they come out and see it in the field, because most inspectors are familiar with it, but it doesn't hurt. When we've had some innovative projects that we were doing with Edison, we would kind of grease the skids ahead of time and go talk to the building department, and that went a long ways in good PR and a smooth project. Here's another shot of George's his Habitat homes a little further along. You can see the roof sheathings on there, and here we've got the he's got some plumbing and wiring gone through there. What doesn't show here too is that he would not pre-notch his studs at the bottom, in the center of the stud, and he like where he's running wire for his outlets, he would run it right on the bottom plate and through the notches in the studs, so he didn't have to drill as many holes. And then having these raised heel trusses saved drilling holes as well. He could run everything up in there. Just a few little tricks and things. And also having this thermal shield doesn't cost you anymore, but you get that radiant barrier in your attic. And well, I wouldn't say it doesn't cost more. The material's a little bit more, but the labor's the same. So it's kind of an inexpensive energy efficiency measure. And here's what we talked about earlier about the single top plate, and then where that code reference was found. And a little more on the insulated corners. Here's on the left side, you can see there's the 2 stud corner with drywall clips. You can see, and I think I've got another slide on. I know in the full class we have slides showing drywall clips. They're not super easy to find. You can't just go to Home Depot and get them, but they save a lot of lumber and they're not that hard to use. They kind of look like a little metal clips they use on the roof sheathing between the sheathing on the gaps between the rafters to keep it from like if you step on it, you don't step through. Kind of helps hold it together. But it's a similar looking clip. And here we've got ladder backing in this outside corner situation being used instead of like a 3 stud corner. And there's just different variations you can use. Like here you've got an OSB sheathing on this inside. Well, this is kind of the outside, but it's an inside corner. And here you got your drywall on the inside of the building. So this shows you what it looks like both directions, an outside corner and an inside corner. And then you would still use drywall clips even on this scenario, most likely. There's also a scenario where you would hold this intersecting stud back an inch and your plate, you hold it back about an inch. And when they hang the sheetrock, they slide it behind there and then nail it up after the sheetrock's hung. So you don't have actually a joint in the sheetrock at that corner. So there's a few little tricks you can use if you can coordinate all your subcontractors. Sometimes when people have a project like if you're doing a big remodel, room addition, or a new construction home, you come out to the Energy Education Center and they'll give you a tour. You can have all your subs there. I've done tours for contractors like that where they had all their subs there and they looked at everything. They could see all the different steps so they could coordinate with each other of what's coming up. Because if you haven't seen it before, it can be a little daunting to try and coordinate everybody. Here we go. Here's the drywall clip. So it seemed like we fabricated sometime out of those roof sheathing clips. I couldn't find any. So here's the question again. Building envelope framing factors. How much or which lumber can be removed? And of course, the answer is any lumber that can be removed without affecting the structural integrity of the building, and of course, is covered by code. Now, this advanced, we call it advanced framing, or sometimes it's called optimal engineering framing or optimal framing. It was first thought of back in the 70s when they had the energy crisis and they were trying to look for ways to save energy on buildings, and this was actually codified way back then. But it's just kind of been there in the code and not everybody knows about it or takes advantage of it, but it's still there. So what's the average framing factor of new homes? We've talked about it a little bit earlier. Also, about 25% or more, but 15 to 18% is realistic on single story and both floors of two-story wood frame buildings. And it's possible even to get down 11% on simple single story designs or the top floor of multi-story buildings. And what's really cool is SIPs are in the 5% range. And what I found with SIPs too is doing blower door tests, they're incredibly tight. If they're built right and you caulked all the panels like you're supposed to, air seal. There was I know one SIP project that in the cold country that was not caulked. They put it all, they just screwed everything together and walked away, and it was a disaster. So as you guys with Passive House know, air sealing's huge. It makes you could have the most insulated house ever built, and if it's leaks like a sieve, it's pretty worthless. They have a lot of freezing issues, moisture issues. And we've talked a little bit about this too already, is you can see the rafter on the right-hand side here, this TJI or truss joist being used as a rafter. And in that situation, this would become non-bearing behind it, underneath it. And so you could have windows or openings over there that would not require a header as long as this is meeting the load calcs up above. And there's also cool roof rating council shingles you can use that are, you don't have to just use a white roof to have a cool roof design anymore. There's just about any color of asphalt type shingles that can be utilized. And we've also got some things in here that show fire resistant. We've got another class on that, wildfire hardening buildings against wildfire, and there's some really cool stuff about that too. That there's a stucco product that we use that'll withstand 3,000 degrees for 3 hours. Very fire safe. So we always comes back to there's all these different ways to nail stuff together, but I personally I like to always seem to come back to SIPs a lot of times. I'm not saying the others aren't good, but this one just seems to be the simplest way to get there. And we also have this display that at the Energy Education Center that talks about, or actually it shows, it's a very good visual and sound. If you look over on the right, you see these ping pong balls on top of these tubes. What we've got here is a hot attic box inside. So we're kind of mimicking a hot attic. And then we've got our outdoor temperature or just mimicking a hot day. But then we've got a fan in here that's forcing air up through these insulations. And over on the right, we've got fiberglass insulation. You can't really see the temperatures here, but typically the temperature on the fiberglass is closer to the outdoor temperature than the cellulose and the spray foam. The cellulose is in between. The fiberglass, that ping pong ball is just about blowing out the top there. That's why they use fiberglass for air filters. It passes air pretty easily. It's not always the first choice for insulation as far as performance. Cellulose passes air through a little less. It's that ping pong ball is barely hanging there, and the temperature is not as close to the outside as say the fiberglass section. And then the spray foam air seals very well, and the ping pong ball just sits there. There's not enough air passing to even move it at all. So that's a really cool visual right there. And then over here on the left, we've got the same three types of insulation. This is actually a open cell spray foam. It's not a closed cell. But there is a little doorbell on each of these, and you ding it, and you can hear on the fiberglass, at a certain level. And then the cellulose, you ding it, and it's a little quieter. And then the spray foam, quieter yet. So this is just a great visual, hands-on display. It's gonna be great for high school, architectural classes to come and take a look at this. There's a lot of learning right there in that center. And we talk about how much lumber is enough. We've mentioned this before. Less lumber also equals less fasteners, less nails, less hangers, less clips, less labor. So hopefully that would mean more profit once you get past your learning curve. There's obviously going to be a bit of a learning curve. But the advanced framing can help achieve higher energy savings and more customer comfort. When I was building custom homes and doing energy efficient, before there was Z&E, they called them super insulated. Some of you probably remember that. I was building super insulated homes and up in Washington State. And there became like a two-tiered market. Those that were super insulated actually commanded a premium because people were asking to see the energy bills. And that was a long time ago. That was more than 25 years ago. And it's just a great feeling when you build a house for somebody and they just say, "Oh, it's so comfortable." I built, and oh yeah, and I save energy too. It was like we always think about the dollars and cents when we're constructing something, but what ends up in the customer's mind, number one, down the road is the comfort or non-comfort, depending on the situation. I built a SIP's house right next to the freeway one time, literally like you could throw a rock. I wouldn't recommend it. Don't throw a rock. But anyway, it was a stone's throw from the freeway. And we put one wall up of SIP panels, just starting in. You had a corner, and you start putting them up. And you got on the back side of the wall away from the freeway, and we were all so impressed with how it cut the noise of the freeway. Just even though there was no other walls up or roof or anything, just having that wall between you and the freeway, how it cut the sound down. Anyway, that's a little off topic, but I thought it was pertinent. So how low can you go? We talked about the emission of the top plate, and here's that reference. This is a picture of it's like I think it's the only, yeah, it is. It's the only 2x4 wall that we put in the display that meets current code. Well, at least it did as of last code cycle. Haven't really got into the 2025 code to see if it still meets code. I think it does. But this has closed cell spray foam, and you can't go 24 on center, obviously, because it's 2x4. But we also did a sealed attic. So, it's basically a conditioned attic. When you do a conditioned attic, that will stay about within 7 degrees temperature of the inside of the house when you don't have any insulation on the ceiling deck. You do it all on the gables and up under the rafters, roof sheathing. So that's kind of that's sort of almost like a second down from SIPs. It's right, performance wise, it's very close. It's kind of like a site built SIPs system. And here's a case study of advanced framing that Will and I did for Edison about 10 years ago. It was an 1,860 square foot, 2-story production home in Ontario. So they were building this these track houses. I can't remember how many was in the track. It was, I don't know, maybe 100. And we got a contract with the builder to let us do one home however we wanted, pretty much. And we did advanced framing. We did all closed cell spray foam with the sealed attic. We used mini splits for AC, the heat pump mini splits, which was 10 years ago. That was very unusual. It's getting a little more common now. Of course, we have PV and high performance windows and doors. But with the framing, I actually was the guy that went out and worked with the framing contractor and trained his crew to build with advanced framing. And we tried to take it as far as we could with it, as much as they were willing to go. We didn't, and if I remember right, they pretty much did everything we wanted, and it didn't always go first time through perfect, but it took a little, it took education, and they were willing to do it. And at the end, um, the lead came over to me and goes, Ron, I can't believe it. We saved 80 studs on this one house. I want to do it with all the houses in the track. I said, hey, talk to the builder. But he really liked it. He was skeptical at first, as I think most people are, because you think, oh, it's not as strong, it's going to fall down, it's going to twist, whatever. But it's not the case. Anyway, I did a rough calculation here. We saved 80 studs, and I can't remember when I priced this out, and I probably need to update it. It goes up and down. But this is just look more less at the number of the dollar amount so much as, 80 studs is 480 nails, say, and then maybe 3 or 4 hours of labor. So on just one house. But then you look at, okay, those 80 studs turned into that much more insulation, which cost a lot less than studs. And you got a more well insulated house out of the deal. So you got a quieter house for sure. So we use ladder backing, 2 stud corners with drywall clips, reducing cripples. Another thing, they sprayed the spray foam after the exterior after they wrapped for the stucco and before they drywalled. So we were able to do blower door tests while the foam was open, and we actually tightened up the house while before the drywall was on with just the spray foam. Found some leakage, and we just kept the door running and went to the store, grabbed a bunch of cans of spray foam and found the leaks and tightened it up. You could watch the number on the manometer drop, drop, drop as we found leaks here and there. It wasn't a lot, but and then we took blower door tests on once they drywalled, once they taped, and once they put the cabinets and plumbing in. It got tighter and tighter until the final finishes when they started cutting penetrations in the plumbing and electrical. Then it dropped. And then when the homeowner moved in and put a doggy door in, it was all over. It dropped a lot. And speaking of blower door tests, here's a blower door. I don't know if you're probably familiar with this, but it's a great tool for just seeing how good you did on your air sealing, and that kind of goes hand in hand with advanced framing. You know, it's not exactly advanced framing, but to me, it's kind of part of it. And what it does is it'll measure every square inch of leakage. Like if you look on the computer, it can take every leak, like you might have a little bit under the wall here, a little bit in the attic over there, but it calculates it all together. So you could say, well, if we put every leak together in one spot, we have a 2 foot by 4 foot hole in the wall or something. And actually, I've done some tests that showed we had like an 8 by 8 foot hole in the wall. You could barely get a test on it. It leaks so bad in some older homes. Newer homes, much better, thankfully. But it's a great test, and you can use it to tighten your house too in new construction and retrofit for sealing attics. It's great. And speaking of air sealing, you can see in the real world over here on the left, this is what framers, this is what we deal with when we're trying to build a house. You know, you don't have, an acre of nice flat ground to frame walls on, and just it's a challenge, let me tell you. So, and then over here on the right, you can see they've gone ahead and put this tape down to help seal under the bottom plate, the sill plate against the concrete. They got this putty tape, which is, it's better than nothing, but that concrete needs to be real flat in order to get a good air seal. And you notice this puddle right here. Well, that tells me with that bird bath there, that's a low spot in the concrete. So definitely you need to lay some more of your tape there, double or triple up that layer, because that's going to leak air underneath that once that's all framed up and put together. So it's just things to think about. And everybody has challenges, and it's a step-by-step process. You got to think about it all the way from the concrete up to the shingles. And I know not everybody likes spray foam, and I guess they're coming up with some better with the GHGs, not so off-gassing as they used to be. So these are better. This was a Z&E community that we worked on in Fontana about 8 or 9 years ago. And I just wanted to get some pictures without screwing up my camera. I got pretty close, but that fine mist got everywhere. But just to show you just how, it's a lot of work too. They use these grills that help keep it from expanding too much. And then they even had to go back with rasp and things and flatten it down to the studs to get the cavities filled nice and even. So it's a lot of work. But what I really like about it is the air sealing ability. You get really good blower door tests with this system. And they also have the fire retardant built into the foam mix, especially for the roofs and attic areas. And then there is a coating that you can paint with also. And then the commercial buildings are using this on their flat roofs as well. And then they put like a hard coating over the spray foam. It works really good. Done that on quite a few commercial jobs. And I mentioned this a little bit earlier. The radiant barrier roof sheathing, it's one of the few energy efficiency measures that has no incremental labor cost. And a few years ago, it was only a couple dollars a sheet extra, but I haven't priced it recently. And then the only other energy efficiency measure that's basically no additional labor is HVAC. You know, you can get a more efficient unit. It's basically the same amount of effort to install it. That one's thanks to Dave. He pointed that one out. It was a good call. And it'll keep your attic cooler, which saves air conditioning energy, especially when you've got your ducts in the attic. So I like radiant barrier as another little trick for low cost energy savings. And we got structural insulated panels. This is again just a little photo of construction. I think this was Nick Brown's ADU that he did a few years back in his backyard. It's a backyard playhouse. And what I like about them, especially when I was building in the Pacific Northwest, is we could get the shell in the dry really quick because it rains a lot up there. And there's less labor, less material waste. The walls are straight and true. You can hang a picture anywhere. My subcontractors I was using when I was building a lot of SIPS homes was the cabinet maker and the drywallers started charging me less. The cabinet maker says, "Hey, I don't have to look for backing. The walls are always true and straight, and I save time, so I'm passing the savings on." And the same with the drywallers; they had less waste. They don't have to cut the drywall back to a stud and then take that piece and toss it. So there is some other advantages there. And there's multiple types of SIPs. There's multiple brands and different types of building systems. They can cost less than traditional in some instances. I know there's some commercial buildings where they were able to delete some structural steel and replace it with SIPs material and actually save money. In other configurations, it might cost you more. But the first cost oftentimes with good material is more, but the long term generally is less. So how much energy can you save? Well, obviously advanced framing significantly reduces the energy to heat and cool a building. It also helps you to comply with the energy code. There's different kinds of credits you can get on Title 24. And let's see, let me look at the chat real quick. I think I want to make sure I'm not missing any questions. If you guys have a question, I don't know, Jay, if you want to.
There are a couple of questions here, if you're ready for questions.
Yeah, let me yeah, we could do that. Let's just do it.
Vincent these were Vincent's, and he was here till just a little bit ago, but he's might have gone on another page. But the first question was, is there a prescriptive one-story approved way to do advanced framing that has guidelines available?
That's a good question. I don't know that advanced framing is considered a prescriptive. I'm not an energy modeling expert, so I'm not the guy when it comes to energy modeling, but as far as if it's in the code, you can do it. You don't have to get a special engineer stamp on something. You can do your 2x6, 2 foot on center. You can leave out your cripples and trimmers, use your hardware as necessary. single top plate, as long as you line up your framing, stack your framing correctly, all that stuff. I would consider that prescriptive in a way. I mean, if that makes sense. It's, I mean, it's not all together in one place in the code. You gotta find it in its specific area, where you've got wall framing or header, calling out headers and different things. It's not all just on one page. If he's looking for that, it's not there. But like on this slide that we're looking at right here, Jay, we've got, here's 6 places that advanced framing helps you meet Title 24. But obviously the advanced wall framing itself, the high performance walls with the in cavity plus continuous outside the cavity insulation. And then we've got high performance attic, like I just showed with the under the roof deck insulation. You can also put insulation on the roof or on the ceiling deck as well as up under the roof deck. Then we talked about alternative building envelopes, SIPs. I didn't really talk about ICFs, insulated concrete forms, but that's another system that's probably more costly per foot, but it's very effective. Raised heel trusses and enhanced air leakage. So there's all these areas give you credit on Title 24. It helps you meet the energy code.
There is a second question from Vincent that is 2x6 walls are great, he says, but they reduce the interior space to the gross area by a percentage. Could code accommodate for this? Example, by allowing for exterior insulating overhang excluded from gross square footage.
I guess you'd have to talk to your individual code enforcement. But I guess I mean, I understand. I mean, that was a lot of the reluctance of builders to go to 2x6 is, you lose some square footage, but I'd say just make it a little bigger. Or you're thinking they should count your square footage on the inside instead of the outside of the footprint? Is that kind of where he was going?
And I believe so, because
Yeah.
you have your setback that you have to go with, and it's the outside of your 2x6 is the edge of the setback.
Yeah, you'd have to talk to your agency having jurisdiction, I'm thinking. That's,
His
I don't,
apparently had to go, so I'm guessing that he did put those in the chat, but
yeah,
he's not here to be.
those are good, thoughtful questions. I like, that's good.
If anybody else has questions to put in the chat, please go ahead, or you can raise your hand, so to speak, if we want to go on through. A couple of things that I can share, Ron, because I was involved when we made the two different when we did the first advanced framing house here in Carmel. And prior to that, I was involved with an organization called Progressive Foam that provided insulation and things. And an example in terms of the framing, you wind up with a 25% framing factor, but with advanced framing, you can get down from that about by 25 or 30% from what it is, and that does save the amount of lumber. And you had the 82 by 80 studs there. But the lumber that you save bigger money on the large, 4x6s and 4x8s that you use as your that are in the walls and things like that, and
Right.
the labor associated with putting it up. You only had the 3.75 hours, but when we did it, Rob said he felt like the framing was done in about 20% less time, so he saved some money there as well. With
Yeah,
respect to
go ahead.
progressive foam, one of the things that we learned there is the 24 inches on center versus 9 inches or versus 16 inches on center is with 16 inches on center. If you have an R13 wall, R13 insulation that you put on the wall, the insulation actually winds up just over 10. It drops just about, so you have to have a higher level of insulation. The more wood you have that is also that is thermal bridging, the higher insulation you get, and that is prescriptive in terms of in Title 24 and in many codes. In this climate zone, you are required to have this R value of the walls, this R value of the ceiling, this R value of the flooring, and things like that.
Right.
And with advanced framing, you not only save money on the wood, you save money on having to add extra insulation to get where you're supposed to be with that. And let's see, look at a couple of things. The two stud what Rob did with his is 24 inches on center, the two stud corners, which save the ladder blocking, which so that you don't have the bridge of the wall going all the way out to the exterior. It is blocked on the inside, and a lot fewer 4x6s over over windows and doors that are not load bearing.
Yeah.
Any other questions from anybody else? Is this is this the end of the presentation, Ron, or you have more slides to go?
It's mostly Title 24 stuff that's somewhat obsolete now with the 25 code that just came out, but there's a few changes. But I wanted to mention that too. We had that list of 80 studs. On that particular house, it was already engineered to have certain headers and things, so we didn't mess with that because we didn't they didn't want to re-engineer the drawings. So we kept with the same headers that they had, but we were able to still save, armload of studs. So
Yep.
you're right there. You could save a lot more than what we did, but for a first run through with a production builder, I thought that was a win.
It wasn't a question, but one other thing in terms of the getting permission and things on things, I would recommend if you're listening in here and you're going to ask for advanced framing, or you're a contractor and you're going to do advanced framing, as opposed to deciding to do it and then just going to put your plans into planning and building. If you're going to use advanced framing, there are a lot of your folks inside the building and planning departments who don't know about it, and reject it or push back on it. So we did learn that when Rob Nicely was doing it, is we would have charrette well before, and get all of the subcontractors that were going to work, and then get the building department to be there so they understood what was going on, as opposed to pushing back because they're not familiar with it.
Yeah, I especially had that pushback in the 80s with the first SIPS houses. The inspector said, "Hey, Ron, I don't think you should do this." They were pretty new then, and now I'm going to do it. Here's all the documentation. It even got a UL listing when we were doing it as a flame spread of 5. So anyway, we did it and it was a success. But yeah, you're right. Meeting with the inspectors and the guys behind the counter as well will go a long ways in a successful project.
Well, you've apparently been really thorough, Ron, because no other questions have come into the chat at this point. If you want to just proceed forward with, you said you have some additional slides that have to do with Title 24, but you're going to skip through them.
Yeah, I'm hitting the down button now, but it doesn't seem to want to go. That's kind of odd. We're stuck. Oh, here we go.
Ah, there you go.
Yeah. Of course, now it's clicking through all of them. Okay, let's go back. Yeah, okay. Yeah, this is just this standard homes that were the Title 24 has the two versions that it's in the modeling. The 2,700 square foot is one of them. But this is off a older code. It's not the one that was just approved. And I want to go through and talk about the windows. I know it's not necessarily this just shows each thing that you did and you get a credit and how much credit each of your things like the 12-inch raised heel trusses it gives you a small credit for each item in the advanced framing. I don't know that we have time to do all that, but here's some other alternative building systems. I like to show a few things that I haven't seen too much of, but they're out there. Like this BAM core is made out of bamboo dual hollow wall, and you can make them as thick as you want. Talk about losing space in the building on the footprint. The ones I saw at a show, construction show, these were a foot apart, and then they could put loose fill insulation or spray foam in between the whole thing. I haven't seen a straw bale install in a long time. I don't know if anybody's still doing any of that stuff. And then rammed earth, I saw one in Laverne or Upland area like around a dozen years ago, a small commercial building. But those are just some other things that are out there. I'm sure there's more. There, there's stuff comes and goes.
Ron, there were a couple of straw bale homes recently done. One was in Ventura, funded by the Chenards, who head up Patagonia, kind of as an example of potentially doing a straw bale home as a production type
Oh
build.
wow. Uh-huh.
And then that same architect with Patagonia did a similar project up in the somewhere in the Central Valley. I can't remember where. I think it was near Carrizo Plain, but yeah, they did some tours of it, and it's actually a pretty nice home, pretty well
Hmm.
designed, really thermally comfortable, all electric.
Wow.
Yeah, it's on the Patagonia website if you want to check it
I
out.
have to check it out.
Yeah,
Yeah, talk about losing floor space at 16 and 22 inches thick. I wouldn't be complaining too much about going from 2x4 to 2x6. Yeah, that's cool. Thanks, Dave.
Just mentioned in the chat that Earthbound Homes, which is one of our sponsors there, up in the Bay Area, they did a straw bale recently in Palo Alto.
Oh, cool. So they are out there. It's not just Mother Earth news from the 70s.
Yeah,
I'm,
well,
da- I'm,
and
I'm
it also
dating
has to
myself.
do with embodied carbon.
Yes.
Straw
Okay.
bales are they're
Okay.
negative.
Yeah, and this talks about the air leakage. And this was kind of a summary of each of the items. The advanced wall framing. It talks about the compliance energy savings you get with each of these. High performance attic was actually pretty good. And if you jump to SIPs, it is really good. You got a pretty, it jumps a lot. And ICFs even more so. And even with tightening up your home, you get a little bit more. You used to get more here because the code homes were so loose, but since they've, cinched up the code every 3 years, there's not as much to gain with this anymore. It's getting harder and harder to go beyond code because the code is actually very good now. And this picture here is what they use this. Oh, I should have put the note on there for you guys, but it's where they spray. It's like a vinyl. It's almost like a paint, but it atomizes it, and they do it for sealing ducts. And we did it on a building. You can do it on retrofit or new buildings, and you put the building under negative pressure with the blower door, and you have this spray. Gosh, I'm not thinking of what it's called now.
I think it's
Okay,
Aero Seal or
there you
Aero
go.
Barrier,
Yeah,
something like
aerosol
that.
seal or aero seal. Right. Anyway, we did it on a community center in Lancaster on a multifamily project 10 years ago. And I was impressed of how it sealed up. We just let the blower door keep running, and they keep injecting more of the spray into the building, and you can just watch the manometer, the fan just slowly slows down as the building tightens up. So and you can do it with duct work as well. So another alternative way to tighten up the building. So,
Yeah.
but you can see you don't get a ton of credit there for that, but you will get a little bit more comfort in the house and it'll perform better. Here's 2025, some of the new stuff in the code. Got this off the Energy Code Ace website. The windows, I guess one of the big changes, and Dave's probably real familiar with this, is the windows have changed from 0.45 to 0.40 U factor. So they keep tightening the noose a little tighter. That includes skylights as well. But I know with our work with the hardening against wildfires, we see this new note here: fenestration installed to meet Part 7 of the California Building Code, located in fire hazard severity zones or wildland urban interface areas. So you have an exception there if you're trying to meet this safety issue, because we've got 1 hour rated windows for fire hazard areas that really don't meet code, the Title 24, because of they haven't actually gone through the official testing, even though they may really be that efficient. They just don't have the sticker that says it. So now there's an exception there for that. So I thought they're moving in that direction, trying to make things more fire safe.
We do have one more question from Michelle Kasunovich, and it is, what is or do you have a favorite type of SIP that you recommend?
I've built with several. I guess I'd have not to, say one company over another, but I used Intercept Building Systems out of South Dakota. They're out of they've I've used a lot of theirs and had really good success with them. I also used R Control. They make a good panel. Use some metal panels too. There used to be it was an oil company that was making metal panels. Can't remember. That's been a long time ago. But they actually use metal studs and foam. I don't think it was as good of a panel as these others. But the takeaways, advanced framing is simple to implement in incremental steps. You can start with one item and work up towards many. And of course, buildings are a system, but one item can affect everything. So think about that. Get your whole team educated and on board before you start. It's always good to have everybody playing on the same page. I've heard it said that a general contractor is like a conductor of an orchestra where every member of the orchestra is in a different union. So it's pretty much, anyway, builders and owners can reap the benefits. It's not, everybody wins on this stuff. It's not just like, oh, the builder's saving money. No, everyone wins.
Well, that's your final slide, isn't it, Ron?
Pretty much.
Uh,
Lessons learned today. How can
yes, if you would, if you will unshare. Oh, though there's some
yeah, and
connections for you.
we can send you, you can send out this slide deck too to everybody if you want. So that's the last slide.
Okay, if you get that back to us, we could put it in and make it available on the Passive House California website.
Sure. Yeah, I sent you the PDF, so you can use it as long as it's okay with Dave.
Yeah, no problem.
All right, great. Thank you.
All right.
If you will, are you unsharing or can you unshare? Because we've got some closing slides here just for a
Okay,
little.
there you go. Sorry.
Okay. Thank you, and thanks all of you for attending. Let me go back to the call to action here, kind of the closing portion. And what you see there in the call to action, first thing is Would like you to know that next week or 2 weeks out on November 12th, we have another webinar coming up, Build It Tight, Ventilate Right by 475. And the link to that, you can find it on the website, the Passive House California website, but the link to that is in the is in the chat, as is the link to the right size plumbing in homes and apartment buildings, which is another one sponsored by Southern California Edison. It's going to be on December 3rd, also a Tuesday at noon. So really, if you want, again, that is also there for you to sign up for. And thank you very much to 3CE for not 3CE, but to Southern California Edison helping us with that going on. And then going to, if you are not already a member of Passive House or involved with Passive House or getting the newsletter, one of the things you can easily do is go to passivehousecal.org, which is down here. And there's a play you can go to the news and sign up for the newsletter, which comes out monthly with all this information on when the next things are. You can get an individual professional membership, an organization company membership. You could become a sponsor, donor, or volunteer. And those are things that are there that you can do. And they're all at passivehousecal.org, which is there. And we will be putting the recording of this presentation up on the it will be going on the Passive House Cal website within several days. We have to get it and then edit down so that it's trimmed. But that will happen within a few days. And so thank you all for your time and attention, for being here. You are, and I use this as slide that by being here and learning this, you become the difference, and you're like the light bulb that's in the center here. The only one of those light bulbs is lit, but it's lighting all the light bulbs around it by the illumination that's going around there. And in any other, well, no other questions in the chat or anything. So I believe we are at we're right at the end time. So again, thank you all for attending, and particularly thank you to Ron and Dave in Southern California Edison and Kim and PHI for handling the technology for us. So thanks to everybody. Stay safe.